Hello, hi. So today I picked one more problem from lead code. So let's jump into problem without wasting time. So let's jump into problem. I will first read, then I will tell you the approach, then we will solve together. Okay. So let's jump into the problem. Okay. So problem statement is find the town judge. So in town judge there are n people labeled from 1 to n. There are There is a rumor that one of these people is secretly a town judge. If the town judge exists, then the town judge trusts nobody, and everybody except the town judge trusts the town judge. Okay, and there is exactly one person that satisfies the property and one and two. You are given an array trust where trust I represent the AI and BI representing the that person labeled AI trust the person labeled BI. So this means like we have a given if you see this example, let me let's take this first example. The problem statement saying for each index means this is had only one index, right? For one zeroth index, we have one another 1D array which is have only two element one and two, right? So it's saying one is trusting on means first person is trusting on second person. Okay, so one and two is represent the level of the person which is the nth means if we have n is equal to 2 means there are two-person, if n is equal to 3 there are three-person, so that's number will be there. So this represent the dependency means one is trusting on uh, person 2. If I generalize as per problem statement for a and b means a trust on b, that's meaning. Okay, so in last return the label of the town judge means we have to return the what are the label of that town the town judge if the town judge exists and can be identified. Okay, or return -1 otherwise. If town judge doesn't exist, we need to return -1. That's the problem statement. So if you see that what the problem statement saying if we have n people, so if you see the condition, town judge trust nobody, but everyone trust town judge except a town judge. So if you are there will be only one town judge, exactly one person which will be a town judge. So if there are n person, so there will be n minus one person of people. We corrected people trust on town judge, town judge. Okay, that's the which can be any nth person. Okay, and town judge which is nth person doesn't trust nobody means it is not trusting to anyone among of all these n peoples. Okay, so if you see that means if you see the given a trust array, it's saying it have a and b at every index, and it's saying that means of a and b a trust on b, that's mean right, a trust on b. So there will be a b which have a count of n minus 1 if there exists one, right? If the judge exists, then there will be a b which have dependency means which have incoming dependency count of n minus 1, right? If you see that, let me take the first example. Okay. For first example, if you see, there are two people, right? And first is trust on two, second one. And condition is also says town judge will be a person which have n minus one dependency. That's the satisfy, and which is the output is two, and two is neither depend on anyone. Okay. Similarly for three, let me just remove the here and let take second example. If you see the second example, there are n is equal to 3, means there are three people. Okay. And if you see that town judge will be a person which have n minus 1, means 2% dependency. Okay. So if you see that three have one have dependency on three, see this one, and second person depend on third person, and first person depend on third person, means there are two person which have dependency on third, and that's why three is the town judge, and three has no dependency. Okay. If you see the third example, there is a, if you see third, only one dependency is added, one extra dependency is added there, which is three is also depending on, means if this is not added, then there will be a town judge. Means third person will be a town judge, but third person is also depending on the first person. So that's why there is nobody who can be selected as town judge. Okay. So what we will need to do? We will need to do count. Means if you see uh, A and B, we need to count how many incoming edges toward it. We need to count of B, means it can similar like this one. Okay, we will need to count of the incoming edge of incoming edge of B. Okay, and we also need to check there no will be outgoing edge from B. Okay, so let's write the code for it. So what I need, let me incoming edge, define the first, we have from 1 to n labeled, so we define it in degree. If you remember that in degree is denote the incoming edges toward that node. Okay, toward that vertex. So let me find n plus 1. I need from 1 to n, means one base indexing. Okay, I also need a somewhere I, so that I can check whether uh, it whoever the we are selecting town judge, selected at town judge, there are no outgoing edges from that person. Okay, or from that vertex, if you think about in terms of the graph. So let me just define it. If you let me, what I needed, just iterate trust array, media trust, and for each a to b, I just need to increase the in degree of the b, do the plus plus at is integer array, and in last, let me define the answer is equal to star. Initialize with -1, start with the I is equal to 1 to n. Okay. If what I need to check, there should be n minus 1, right? N minus 1 incoming edges, n minus 1 dependencies to that vertex, and to that uh, person who will be going to select as town judge. So there should be n minus 1, right? Then just update the answer with that labeled and break the loop, and in last just return the answer. But I need to check whoever I'm going to select as a town judge. There's there should not be any outgoing agents. There should not be any dependency. Okay. So let me define for that one what I need to check. I need to check. Let me find the hash set, hash map. Okay. So have an integer. Let me define a boolean. Okay. Mm, let name it as hash uh, mm, edges, right? New hash map, correct? So if you iterate this one, this have A and B. It represent the A depends on a B. Means person B, person A depend on B means person trust on person B. That's why I am counting the how many person trust on the person B. That's the count. But I also need to check if that B person if has any edges or not. Means outgoing edges has it has. If it should not have any outgoing edges, that's why I needed here. So let me just do it. What I need to do, if A and B means A trust on B. So I need to put A means which is the zeroth index. Just put a true value. Means this particular uh, person have a trust on someone else. Okay. We don't need to store all the person whoever trusting on this person. We just need to check, right? So that's why. So I just this will help us here. So check contains key for I and so this is showing that a ith person doesn't have any trust on any other person. Means the ith person trust nobody. This will condition this will this condition checking the ith person has trust on nobody, and it has everyone trusting means n minus 1 means there are n minus 1 people who is trusting the ith person. That will be the town judge. Okay, let me run it. Okay, so sample test cases got passed. Let me submit it. I hope it got accepted. Yeah, so this is the easiest one problem, but there is twist like interesting one. That's why I have picked this problem. Uh, so yeah, this is all about. Okay, happy coding.